Hi class, this is section 5.2 part 2. This time we will be talking about medians and altitudes in triangles. We will be able to use properties of medians and altitudes in triangles. That's our learning target. So, what does it mean for lines to be concurrent? This is what the first video was over. Concurrent lines intersect at one point. So it's where we have three or more lines intersecting at a point. Here's some quick new vocab. The blank of a triangle is a segment whose endpoints are a vertex and the blank of the opposite side. So to fill in these blanks, we're going to fill in the words median and midpoint. So the median of a triangle is a segment whose endpoints are a vertex, so like A, and the midpoint of the opposite side. So it would go from A to the midpoint of BC. Just like that. Here's the median that's going from B to the midpoint of AC. And here's the median that's going from C to the midpoint of AB. Here is our first theorem. The medians of a triangle are concurrent at a point called the centroid. That is 2/3 the distance from each vertex to the opposite midpoint. So here is our triangle ABC. Let's go ahead and draw in all three of our medians. Now, I want to point out a median does not have to be perpendicular to the opposite side. All it has to do is go from a vertex to the midpoint of the opposite side. We show that it's a midpoint by marking the two halves congruent. So here's our first median, our second median, and our third median. The point where they're concurrent right here is called the centroid. So I'm going to put in some extra letters to label the opposite end, like the midpoint of where all these are meeting. And then here's our centroid at point G. So we are going to find AG, EG, and CD based off of this information over at the right. So this one can be the most challenging because it has to do with multiplying by a fraction. So what it's saying is that if I was, say that A to F was 1, well, A to G is 2/3 of that distance. So AG is 2/3 and GF is 1/3. So if you add those together, it makes 3/3 or 1. So this is saying that AF, the whole thing, is 18, and we need to find AG, which is 2/3 of that. There are two ways to do this. One way is that you can multiply this 18 by 2/3. So just multiply 18 by 2 and then divide by 3. And that would give you your answer. Or you could find 1/3 of this distance by dividing by 3. That would give you 6. And then we know that AG is 2/3, so that means AG would have to be 12. So again, if we multiplied this by 2/3, it would be 36/3, which is 12. Or we can find 1/3 of this and then just multiply that number by 2. Either way, you guys will have to do a little bit more work for this type of problem. So this one tells me that BE, the whole thing, is 30, and we want to find EG, that smaller part. So that's going to be the 1/3. So 1/3 of 30 is going to be 10. This one tells me that CG, the 2/3, is 4, and we need to find CD, which is the whole thing. So 2/3 of it is 4. That means that 1/3 of it would have to be 2. So if we do 4 plus 2, we get 6. So we know that CD is 6. Let's spice things up a little bit. Given that G is the centroid, if B is 21, find BG and GE. So we're going to find two different parts. So BE is the whole thing, and that's 21. 1/3 of that would be GE. So 21 divided by 3 is 7. That means that GE is 7. BG is 2/3, so it has to be twice this amount. So that would be 14. 14 plus 7 equals the whole 21. So again, BG is going to be 14 and GE is going to be 7. Next one, if GF, the 1/3 part, is 6, find AF. Well, if 1/3 of it is 6, then the whole thing, to find that, we would just multiply by 3. So AF is going to be 18. Another way you could do it, if this is 1/3, it's 6. 2/3 would be multiplying that by 2, which would be 12. 12 plus 6 is 18. Alright, some more quick vocabulary. The altitude of a triangle is the perpendicular segment from a vertex to the line containing the opposite side. Notice it says the line containing the opposite side. We will not always be able to draw an altitude directly to the opposite side. We may have to extend that opposite side to draw the altitude. So, it may be the side of a triangle, or it may be the outside, be on the outside of a triangle. So, here's our first triangle. To draw an altitude, we need it to go from a vertex, and it has to be perpendicular to the line containing the opposite side. So here's an example of an altitude. Notice this is not a perpendicular bisector. It's not cutting BC in half. It's just a line going from A to BC, and it's perpendicular to BC. Another example would be going from C and perpendicular to this side. Alright, here's another triangle. This is a right triangle. In right triangles, the sides are actually going to be altitudes. So if I drew a line from D perpendicular to the opposite side, it would have to be the side DE, because this is a right angle. The same thing's going to happen on the bottom if we were to draw an altitude from F to from F to ED. And then here's the last kind of triangle. So we have an acute triangle, a right triangle, and an obtuse triangle. So one altitude we could draw on this obtuse triangle is from J to the opposite side, which is KL. But notice I could never draw a perpendicular segment within the triangle, so this altitude actually falls outside of the triangle. It's perpendicular to the line containing the opposite side. The same thing happens if you try to draw an altitude from K to JL. It's going to fall outside of the triangle. The lines that contain the altitudes of a triangle are concurrent, which means they meet at a point. Is the given segment an altitude, median, or neither? So in this triangle, we have a lot of different segments drawn. First, let's look at AF. AF is going from a vertex and is perpendicular to the opposite side. That means that it's an altitude. BE. BE is going from a vertex to the midpoint of the opposite side. That means that it is a median. DE. DE is going from the midpoint of one side to a midpoint of the other side. This is going to be neither. It's just a mid segment. It's going from two midpoints. And finally, CD. CD is going from a vertex to the midpoint of the opposite side, so that's going to be a median. More examples. Given that M is the centroid, meaning that it's where all the medians are meeting, we're going to find WX and MX given that WM is 16. So remember, the centroid is where you use that 2/3 property. So WM is actually 2/3 of WX, the whole line segment. So if 2/3 is 16, then we know that this 1/3 part right here has to be 8. It has to be half of that. So MX is 8, WM is 16. That means WX has to be 24. So our two missing pieces are 24 and 8. Alright, now using this triangle, we are going to identify the following. So first we need to identify a perpendicular bisector. Well, the perpendicular bisector in this triangle could only be NX. Notice that it's perpendicular to this side and it's cutting this side in half. An angle bisector. The angle bisector in this picture is BY. It's cutting an angle in half. The median has to go from a vertex to the midpoint of the opposite side. So that's also going to be BY because it's going from vertex B to the midpoint of AC. And then an altitude. The only altitude in this picture is CZ. It's going from a vertex and it's perpendicular to the opposite side. That's the end of this video. Please make sure to fill out your WSQ and I will see you in class.